Okay, guys, so one of the things that I want to talk about, or that we need to talk about, is arithmetic sequences and series. The nice thing about arithmetic sequences and series is they're the easy or type of the sequences and series that we'll be talking about. Tomorrow in class, we'll be talking about geometric sequences and series, so you want to make sure that you get a good feel for this sometime today if you can. Also, make sure that you have printed out the notes, because I'm basically going to be filling in the notes, and that's what you're going to see me doing on this video. So if you don't have the notes, you're going to be wondering, what the heck am I talking about? So according to the definition that's written in on your notes, it says an arithmetic sequence has a common difference between consecutive terms. Okay, look at your example, 2, 11, 20, 29, 38. As you can see, if you just do a little bit of quick math, there is a common difference of 9 between each of those consecutive terms. If you take any two terms and subtract them, you end up with 9. Okay? So looking at the next part, determining whether or not the following sequences of numbers are arithmetic. If they are, find the common difference. Well, for number 1, you have the sequence 2, 4, 7, 11, 16. Well, between 2 and 4, I have a difference of 2. Between 4 and 7, I have a difference of 3. Between 7 and 11, I have a difference of 4. And between 11 and 16, I have a difference of 5. Those are not the same numbers, so this is not an arithmetic sequence. Okay, it must have the same difference. Take a look at number 2. We have 19, 23, 27, 31. Again, some quick difference there. I have 4 between 19 and 23, 4 between 23 and 27, and 4 between 27 and 31. So yes, this is an arithmetic sequence. It is important that you understand the difference between a common difference and a common multiple. Okay, this is a difference. You subtract. Okay, so where it says section A, writing the rules for the nth term of an arithmetic sequence, that's actually very straightforward. This is the rule. A sub n equals a sub 1 plus n minus 1 times d. The things that you need to know, obviously a sub 1, if you were paying attention yesterday, that is the first term. Okay? This is kind of like a recursive formula used to find an explicit formula. Okay, D here is the common difference. So if you are subtracting, like in number 2, and you've got the same thing as you got 4 over and over and over again, 4 would be your D. That is the common difference. Okay. So let's go ahead and try a couple of these out. All right, so number 1, you have the rule 2, 11, 20, 29, and 38. And it says to write the rule and then find a sub 15. Well, you should know that a sub 15 is the 15th term, but in order to do that, we need to find the rule. So basically, the rule says a sub n equals a sub 1, the first term. Well, they give us the first term, which is 2, plus the formula n minus 1 times the common difference. Well, what's the common difference between 2, 11, 20, 29, and 38? That's just simply 9. Okay? Please make sure when you're simplifying this that you distribute, because this is n minus 1 times 9, so this becomes 9n minus 9. Okay? Make sure you distribute and then simplify. So this ends up becoming 9n minus 7. So a sub n, in this case, is 9n minus 7. And then the last thing that you need to do for this problem was to find a sub 15. Well, a sub 15 is just simply what? 9 times 15 minus 7. Well, if you do that math quickly, you end up with 128. Okay? All right, so let's move on to number 2. Number 2, you're given 12, 7, 2, -3, -8 as your sequence. Okay? Again, we need to find the rule. We need to write the rule and find the missing terms. Okay? Well, actually, you're not. Sorry. You're given 12 and -8. Sorry, I was looking at my notes. All right. And you're supposed to find the rule and find the missing terms. Well, your first term, a sub 1, is equal to 12. Your fifth term, okay, because they gave you the 3 blanks in between, your fifth term, a sub 5, equals -8. Okay, so basically what we need to do is we need to find D, right? We need to find the common difference. Well, this is pretty straightforward. Just plug it into your formula. A sub n, well, n is 5, so a sub 5 was -8, equals a sub 1, which is 12, plus the quantity n minus 1 times D. Well, in this case, n is 5, so I'm going to replace the n with 5 because it's the fifth term that we're doing. So I have -8 equals 12 plus 4D. So -20, do your math correctly, is equal to 4D. So then doing the division, I get -5 equals my common difference. So that means that I'm going to step down by 5. I'm going to subtract 5 from the previous term to get the next term. So a sub 2 is just simply 12 minus 5, or 7. A sub 3 is equal to 7 minus 5, or 2. And a sub 4 is equal to 2 minus 5, or -3. Hence the reason that I said that you have 7, 2, and -3 for those 3 blanks. And that's how we got it. Okay, let's get a little bit more complicated. This time I'm giving you a value of a sub 13 equals 30, and I'm telling you that the common difference is 3/2. Well, again, go right back to that equation. A sub n equals a1 plus n minus 1 times d, and fill in what you know. A sub 13 is 30, so I'm going to put 30 equals, I don't know my original a1, but I do know everything else. This is 30 minus 1 times d, which is 3/2. All right, so I have 30 equals a sub 1 plus 29 times 3/2. Yep, made a mistake. What did I do? Well, remember, a sub 13 is 30, so n is not 30 at all. All right, let's try this again after being interrupted several times. The mistake I made was I said that n was 30, but it's not. It's a sub 13, so this is the number 13. This is the 13th term. So please try to, not rush like I am. And then 13 minus 1 is 12. Okay, so then I have 12 times 3/2. Right? So 30 now equals a sub 1 plus 18. And so 12 is my original number, a sub 1. And it says to write the rule. So now the rule is very simple. Okay? A sub n is equal to 12 plus 3/2 n. Okay. Now, once again, here I am rushing. So let's back up. Okay. remember our original formula, a sub n equals a sub 1 plus n minus 1 times d. Okay, now what do we know? We now know a sub 1 is 12, but we still need to readjust our formula. So a sub 1 is 12 plus, now I've got n minus 1, so n minus 1 times 3 over 2. So I now have a sub n equals 12 plus 3 over 2n minus 3 over 2. So a sub n is equal to 3 over 2n, and then you have 12 minus 3 over 2, which is plus 21 over 2. So there is your formula. And I'm going to try and slow myself down and stop making so many silly mistakes. All right. Okay, so now all you're given is 2 points. A sub 4 equals 16 and a sub 10 equals 46. The thing that you need to realize about this is, remember, there is a constant difference between each of these points. Okay? So how do I find that constant difference? Well, this is kind of like a slope. This is an x value. This is a y value. This is an x value. This is a y value. So you have two ordered pairs. How do you find the slope of the ordered pair? The slope is the constant difference. Okay? So basically, all you have to do is take your y values, 46 minus 16, and then, of course, divide by your x values of 10 and 4. So 46 minus 16 is 30. 10 minus 4 is 6. So the constant difference is 5. And that should make sense. So a sub 5 would be 21. A sub 6 would be 26. A sub 7 would be 31. A sub 8 would be 36. A sub 9 would be 41, and a sub 10 should be 46. Do you see how this gave us our constant difference of 5? Just treat it like it's a slope problem. It's that easy. Okay. Now we need to actually write our problems. Okay. A sub n equals a sub 1 plus n minus 1 times d. Well, we don't know a sub 1, so we're going to have to figure that out. So we have to use either the a sub 4 equals 16 or the a sub 10 equals 46 to figure out a sub 1. So this is the hardest problem just because it has the most work. It's not because it's a difficult type of math. All right, so I'm going to use the smaller numbers just because I can. So a sub n is 16. Okay. We don't know what a sub 1 is, but we do know that n is 4. So I have 4 minus 1, and we know our constant difference is 5. So I now have 16 equals a sub 1 plus 15. So 1 equals a sub 1. All right, so now we got to write our formula. Okay? A sub n equals 1 plus the quantity n minus 1 times 5. All right, now let's work it out. A sub n is equal to 1 plus 5n minus 5, or a sub n is equal to 5n minus 4. There we go. We now have worked it out and have figured out the equation. Okay? All right, so let's move on to part B. Part B, on your notes, there are two rules for the sum of an arithmetic sequence. Okay? The first rule, S sub n equals n divided by 2. And what does it say? It says times a sub 1 plus a sub n in parentheses. So remember, a sub 1 would be the first term, And a sub n would be whatever the last term is, or whatever the nth term is. Okay? So this is a nice way of being able to add up all of the numbers in a sequence without actually having to add every single number. Okay? But it's really important that you are able to you have to know the sequence. Okay? All right. So look at the example. It says, given the series, that should be a sequence. Well, it is a series because you're adding it. 3 plus 6 plus 9 plus 12 plus ... Find the sum of the first 50 terms. Now you can do this the hard way. You can do, okay, 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21, blah, 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 and make sure that you don't count too many. Or you can actually do this the easy way. First thing you need to do is you need to find the rule that created the series. Okay? So first off, we have a sub n equals a1 plus n minus 1 times d. Okay, this is the stuff that we just did. Okay? So what's our common difference? Our common difference is 3. What's the first term? That is also 3. So a sub n equals 3 plus n minus 1 times 3. Or a sub n equals, goodness gracious, there we go, 3 plus 3n minus 3. Or a sub n is just simply 3n. Okay? Now, part B. Since you want the sum of the first 50 terms, you need to find the 50th term. Well, the 50th term is easy. A sub 50 is just simply 3 times 50. Okay? So in this particular example, a sub 50 happens to be 150. Great. Now let's do part C. Now you can find the sum by substituting the values into the formula. Remember the formula, okay? The sum of the first, telling you my stylus is really bad. The sum of the first 50 terms is just simply n over 2 times the quantity a sub 1 plus a sub n. Well, so the sum of the first 50 terms is going to be 50 divided by 2 times the first term, which was what? Well, that was given to us, that was 3, plus the 50th term, which is 150. Okay? So the sum of the first 50 terms is going to be 25 times 153. And so 25 times 153 turns out to be 3,825. So I think that you all can see the very big benefit of this particular formula showing up, because all of a sudden I don't have to start at 3 and count by 3's 50 times. All I have to do is know the first term and the last term and remember this formula, and we're good. Okay, so let's try another one. The next one, 4, 7, 10, 13, and find the sum of the first 30 terms. All right, so again, we have to figure out what the formula is, and we know how to do that. So I'm not going to write the formula all the time. That's going to be 4 plus n minus 1 times 3. Or a sub n is equal to 4 plus 3n minus 3, where a sub n is just simply 3n plus 1. Cool. Now we need it says find the sum of the first 30 terms, so let's find the 30th term. A sub 30 equals 3 times 30 plus 1, and this is clearly an explicit formula now, so we now have 90 plus 1, and that gives me 91. All right, so now what's the sum of the first 30 terms? Well, we have 30 divided by 2. Just going back to the formula. We have the first term, which was 4, plus the 30th term, which was 91. So I have 30 divided by 2 is 15. 15 times 95. All right, so what is 15 times 95? Well, that's simply 1,425. See how easy this fun stuff is? All right, let's try number 3. We are given a series of 16, and then 10, and then 4, and then -2, and it goes all the way down to -128, and then it says find the sum. Whew. This is a little bit different, okay? But it's really not. First off, S sub n equals n over 2 times 16 plus negative 128. But we don't know how many terms there are in this, do we? Okay? So in order to figure that out, we have to go back to our other formula and say, okay, what's n? Well, let's figure it out. So we've got a sub n is equal to 16 plus n minus 1 times how much? Well, it's going down by 6, so -6. Okay? So a sub n is going to be 16 minus 6n plus 6. Or a sub n is going to be -6n plus 22. But that still doesn't tell us what n is, but we can figure it out because we now know that, remember, the last term, the nth term, is -128. So we're going to plug in -128 is equal to -6n plus 22. And let's do the math. This becomes -150 equals -6n. And then we divide, we get 25 equals n. So now this is the 25th term. How awesome is that? Now we know what we have to do over here. So the sum of the first 25 terms, the sum of the first 25 terms is just simply 25 over 2 times 16 minus 128. Well, this time I'm going to do 25 times, let's see, 16 minus 128, that is -112 over 2. Yes, you can do that. I already hear you're like, what? Huh? I don't understand. I always try to make one of these two numbers is going to be even, the other one's going to be odd. I always just divide the even number by 2. Makes life a lot easier. And yes, you can do that. So I get 25 times -56, so the sum is -1,400. And that kind of makes sense. I mean, we're starting positive and then going in a big negative direction. So the sum of that of that sequence happens to be -1,400. Right. Almost done. So as your note says, we can even use the sum formula when sigma notation is involved, provided that the series is arithmetic. Okay? So we want the sum from n equals 2 to 50 of 10n plus 15. Okay, so when n equals 2, that's the first term, we're going to have what? 10 times 2 plus 15, and that's going to be 35. And then when n equals 50, we're going to have 10 times 50 plus 15, and that's going to give us 515. Okay? That's the first term and the last term. Now, how many terms is that? Well, the number of terms is simply 50 minus 2 plus 1. Guys, you've got to remember that this is 48, but there's actually 49 terms here, right? 1 to 50 would be 50. 2 to 50 would be 1 less, so it would be 49. So n equals 49. Okay? So what do? Well, S of 49, sum of the first 49 terms in this sequence, is just simply 49 over 2 times 35 plus 515. All right, so I got 49 times 550 divided by 2. So I have 49 times 225, which gives me a grand total of 13,475. So we have, finally, to end our notes and the video, we have the sum of n equals 6 to 28 of 5n minus 17. So let's figure out a sub 6 is simply 5 times 6 minus 17, which equals 13. And now let's figure out a sub 28. Well, that's 5 times 28 minus 17. And that turns out to be 123. All right, so what is n? N is 28 minus 6 plus 1. So 28 minus 6 is 22 plus 1, so there's 23 numbers here in this sequence. So S of 23 is going to be 23 of the first 20 of these 23 terms, going to be 23 divided by 2 times 13 plus 123. Okay, so S of 23 is simply 23 times 136 divided by 2, which is 23 times 68. Okay, and then 23 times 68 will be 1,564. So the 23 terms in that sigma notation add up to be 1,564. So not bad, okay? You guys can do this. All right, do your homework.